doing one of these by hand, I go out and I do it this way as well. Okay. Cool. So this is our algorithm. I'm going to do an example now of this, and then I'll tell you what a reduced matrix is, and then maybe we'll see where we're at what time. See what we do next. So this is what we're going to try to do. So let's see an example. We'll just do a system of two equations. I wrote down a specific one I wanted to do. Make sure I get it up here. So here is our, I really want to write this up on the board. I guess this is fine. Okay, here's our system of equations that we're going to solve using a matrix. So I'll just kind of have this up here as a reminder that this is what we're doing. So the first thing I need to do then is just write down the augmented matrix. That's always where we're going to start when we're solving a system of equations like this, is just write down the augmented matrix. So let's do that. Again, we're just going to fill in the numbers from the equation. So it'll be 1, 1, -4. And then it'll be -3, -4, 5. Okay, so there's our augmented matrix. And now I want to run the algorithm that I just described on this matrix. And so step 1 would say, get a 1 in the upper left corner. In that first row, first column, we'd want to make a 1. So right here, I want a 1. We already have a 1. So we're good. We don't have to actually do anything for this first step here. We already have a 1 there. Now, step 2 would say, since I have the 1 here, I want to now make zeros everywhere else in the first column. Here's our first column. I have a 1. I need to make a 0 here, where the -3 is. So I need this to be 0. -3 needs to be 0. I need to cancel that out. And so what are we going to do? We're going to say, the only way to change this into 0 is to add something to it, to add this first row or some multiple of it to the second row. So what I'm going to do is, well, what do I do to cancel out -3? I need to add +3 to it. So I'm going to multiply the first row by 3 and add it to the second row. So we're going to take 3 times the first row plus the second row. We're going to change only the second row. Okay. So I need to multiply everything up here by 3 and add it to the corresponding guys down here. So that's -3 plus 1 times 3. That's -3 plus 3. That's 0, like we wanted. Good. -4 plus 3 times 1. That's -4 plus 3. That's -1. And then I have 5 plus -4 times 3. That's 5 plus -12. That sounds like -7. -7. So my new second row is 0, -1, -7. And then I'm not going to change the first row. So here's my new matrix. And so we notice this first column now fits what I wanted from the algorithm. I got a 1 in the corner, and I have a 0 down below. So it's only a 1 and then zeros in the first column. So now the first column is done. Let's move on to the second column. The idea now is that I'm going to go to the second row, second column, which is this guy right here. And I need this to be 1. That needs to be +1. It's -1 right now. So how do I turn -1 into 1? Well, probably the fastest way to do that would be to just take the second row and multiply it by -1 or divide it by -1. Because -1 times -1 is +1, right? So let's take -1 times the second row. Just to make this into a +1. I'll make our lives a little easier. And we'll follow the algorithm. So that'll give me 0, 1, +7. I'm just going to change the signs on those guys. And then I haven't changed the first row. That stays the same. Okay. Now, according to the algorithm, now that I have a 1 here in the second row, second column, I now want to use this one, and I need to get zeros everywhere else. So this one up here needs to be 0. And my handwriting is deteriorating over here. Needs to be 0. I need to turn this into 0. Okay. How do I do that? All I need to do is ask, what is the opposite of 1? Well, it's -1. So maybe it seems sort of silly that I did this, but we're just following the algorithm. Let's take -1 times the second row and add it to the first row, yeah? So let's do that. Take negative second row plus the first row. We're going to change the first row. It's not entirely silly that we did it this way, because now this row will stay intact like this. And we'll be able to more easily read off our answer here in a second. I'll show you what I mean. So we take -1 times the second row and add it to the first row. So 1 plus -1 times 0, well, that's just 1. 1 plus -1 times 1 is 1 plus -1, which is 0. And then -4 plus -1 times 7 is -4 minus 7, which is -11. And I didn't change the second row. So here's my new matrix. And this is actually my final matrix. I will tell you that this is what we're going to call reduced. This is an example of a reduced thing. So this matrix, this is reduced. I'll give you an explicit definition of reduced in a second. That's a reduced matrix. One way to notice this is that I have these like ones that go down diagonally. There's this like diagonal of ones, and then everything else is 0 to the left of the bar. So I only really care about to the left of the bar. I have these ones on the diagonal, and everything else is 0. This is an example of something that's reduced. So if you see this, you know your matrix is reduced, and you know you are done solving the matrix problem. Okay, so I tell you that we're done. So let's reinterpret this in terms of the system of equations so that I know what the solution is supposed to be. Because this, I don't know what this means yet, right? If I asked you to solve this and you just gave me this, I don't know. I don't know what this means yet. So let's reinterpret it in terms of the variables x and y, what they have to be. So remember that this first column is like the x column, and the second column is the y column. And then this vertical bar is like the equal sign. Yeah? And each row is an equation. So this is telling me that the coefficient of the x in the first equation is 1, and the coefficient of y is 0. And then that should equal -11. Well, y is 0, so this is just telling me that x equals -11. This tells me that x equals -11. By the same reasoning, this tells me that y is 7. Y is 7. And so this is our solution. X is -11 and y is 7. We're done. By reducing the matrix, it just spat out the answer for us. Just gave it to us. Okay. So this is a good spot for me to pause for questions again. Let me just point out that all we really did was the same stuff we would have done for the elimination method to solve this, which we could have done. But again, we just encoded everything with a matrix. And the reason we want to do this is because even though maybe it seems like it would have just been easier to do the elimination method here, and maybe that's true, if this was a bigger system of equations of like 3 or 4 equations, which you guys will be asked to solve pretty soon, doing that with the elimination method is just not a pleasant experience. And it'll actually be easier in the matrix format. So the matrix format is going to let us do more complicated problems than we really could do before. Okay. Anyway, this is a good point for me to pause for questions if anyone has any. Again, I've been talking a lot. Okay, and let's see, we have about 18 minutes left. So what I want to do really quick is write up here what I mean by reduced matrix a little more explicitly. And then we'll see where we're going to go from there. Maybe I'll get you guys started on an activity to start practicing this stuff, because really, yeah, pretty much the only way to learn this is to practice it a bunch. I just want to do a bunch of practice. So you could watch me do problems all day, but you won't really learn how to do it until you've done it yourself a bunch of times. So let me just tell you what reduced matrix means, because there's going to be other examples of reduced matrices that are a little weirder. And let me give you another definition first. There's something we call a leading one. A leading one. This is a 1 in your matrix. So this is a, write it this way. This is a 1 in your matrix. So that there's going to be two conditions, I guess, we'll say here. The first condition to be a leading one is that every other, or maybe not every other, let me put it this way. Every entry below it is 0. So everything underneath it is 0. The things right above it, oh, I guess actually they should be 0. Yeah, okay, never mind. Let me rewrite this. It is just every other entry in the column. Every other entry. Messed up my Y. In its column is 0. So it's the only non-zero thing in its column vertically. And then every entry to the left, to its left, it's also 0. Okay. So this is a leading one. Every other thing in its column is 0. Everything to the left of it is also 0. So let me give you an example. Do it this way. Here's a matrix. I will circle all the leading ones for you. And then compare them to the definition. So here's a leading one up in the corner. As long as this number is a 1, it's automatically a leading one. And then the only other leading one is this guy right here. Because if you look in their column, they're the only thing that's not 0. And to the left of this guy, everything is 0 in this row. And there's nothing to the left of this one, so I don't have to check that. So those are my two leading ones. Let me give you another example here, or maybe there's something that's not a leading one. Okay, here's another matrix. Let me circle all the leading ones here. This is a leading one, again, because it's 1 in the upper left corner. But that's the only leading one. This almost could be a leading one, but the problem is it's not the, there's a number in its column that's not 0, namely there's this 2. I would need to make this into a 0 for this to be a leading one. So this is not a leading one. There's only one leading one here. So in some senses, we're about to see this is not a reduced matrix. I would need to kill this 2 to make this into a reduced matrix. So something about leading ones has to do with this reduced matrix business. Okay. So that's a leading one. That's just a bit of terminology that I'm going to use to tell you what reduced means. But probably what will end up happening is if you practice this enough, after I tell you what reduced means, and you've seen enough examples and you've worked through enough problems, you'll kind of just be able to see when it's reduced or not. It should just catch your eye whether or not it's reduced. So hopefully you'll get pretty good at identifying these.